so we just had some practice going from degrees to radians. Now we're going to go the other way. Suppose I give you a radian and I want to convert to degrees. It's a very similar conversion formula, except now we're going to multiply by 180 degrees over pi. So what we're going to do, and again they want us to draw each angle. So to convert pi over 6 into into degrees, I'm going to multiply by 180 degrees over pi. Notice we want that pi symbol to cancel out. And notice I'm bringing in a degree symbol here. So I'm left with 180 degrees over 6, which is equivalent to 30 degrees. So when I sketch 30 degrees, there's my initial side. My terminal side is going to be in quadrant 1, and again it's a positive angle measurement, so I'll show that counterclockwise rotation. So it is in quadrant 1. So 30 degrees is equivalent to pi over 6. Now 3.89, be careful, you're not seeing the degree symbol, so remember this is a radian measure. Well, the pi symbol, you ask, where is that pi symbol? Remember, radians can be measured in exact or approximation. So since there is no pi symbol here, we know it is measured in an approximate radians. But the conversion formula is still the same, it's just you'd be using your calculators. So I'm going to take 3.89 and I'm going to multiply it by 180 degrees over pi. So on my calculator, I'm going to take 3.89, I'm going to multiply it by 180, hit enter, and then I'm going to divide by pi. So I end up with 222, and again it's an approximation, so I'm going to use that squiggly equal sign, 222.881 degrees. We always round our answers to 3 decimal places. That's our standard rule of thumb. So now I can sketch the angle. Again, I know that it's going to be larger than 180, and I have to go about another 42.8 degrees. So that's what the angle of 3.89 radians is going to look like. Negative 5 pi over 3. Again, to convert it into degrees, I know it's going to be a negative angle measurement. I'm going to multiply by 180 degrees over pi. Notice my pi symbols are gone, and I can take 3 and divide it into 180, which will be 60 degrees. So negative 5 times 60 is going to give me negative 300 degrees. So negative 300 degrees, again there's my initial side, here's negative 90, negative 180, negative 270, and then I need to go another negative 30 degrees. So that's going to put that terminal side right there in quadrant 1. Make sure you show that clockwise rotation. So that's what negative 300 degrees or negative 5 pi over 3 is going to look like. Negative 13 pi over 6. So again, I'm going to multiply by 180 degrees over pi. The pi symbols are gone. 6 goes into 180 30 degree times. And 30 times 13 gives me 390. So this is equivalent to negative 390 degrees. So negative 13 pi over 6 is equivalent to 390 degrees. So I know it's going to be more than one complete revolution around. Again, remember you're going in that clockwise rotation. So there's my negative 360. So when I take away negative 360 from negative 390, that's going to give me another negative 30 degrees. So I know that that terminal side is going to be located down here in quadrant 4. So that's what negative 390 or negative 13 pi over 6 is going to look like. So again, here's some more practice of going from radians into degrees. So pi over 4. So another way, instead of, eventually we're going to be working all year more in radians than in degrees. So it's going to be really helpful to get your brain, so you're not going to convert everything all the time. So this is the way I get my brain to start thinking in terms of radians. I know that this is going to be 0 radians. This is going to be pi over 2. 90 degrees, if I did my conversion formula, is pi over 2. Notice this is a fraction. I know that this over here would be 180 degrees or just pi. Well, I can express pi a lot of different ways. Pi is equivalent to 4 pi over 4. If I was to simplify that fraction, that would simplify down to pi. This right here would be 3 pi over 2. 270 degrees, if I did my conversion formula, would be equivalent to 3 pi over 2. So if you think now about where pi over 4 is going to be, pi over 4 is, I know, halfway between 0. I know that 1/4 is halfway between 0 and a half. So I know that pi over 4 is going to be right here in quadrant 1. Or like I said, until your brain gets comfortable with radians, I know I can convert this into 180 degrees over pi. I can cross out the pi, and then 180 divided by 4 is going to give me 45 degrees, which is where I landed right here in quadrant 1. So now 7 pi over 4. I know that this is going to be 4 pi over 4. I know if I make one complete revolution around, that's 360 or 2 pi. Well, another way to think of 2 pi with a common denominator of 4 would be 8 pi over 4. If I simplify 8 pi over 4, that is 2 pi. So where do you think 7 pi over 4 is going to land without doing that conversion? Well, 7 pi over 4 is going to have to be down here in quadrant 4. 7/4, 1 3/4 of a way. So that's what the angle says. Again, I'm trying to get your brains to think a little bit, how am I going to think about this in radians all the time? Because that's what we're going to work in most of the year. We're going to work in radians versus degrees. So then so that's what 7 pi over 4 is going to look like. And then when I multiply by 180 degrees over pi, the pi's cancel. 7 times 180 divided by 4 is going to give me 315 degrees. 7 pi over 6. Again, if this is 0 degrees, that's the same as 0 radians. This is going to be equivalent, again, I'm looking at the common denominator, I want everything to have a denominator of 6. Well, pi over 2 is a half. Well, I can express a half as 3/6, or 3 pi over 6. This would be 6 pi over 6. If I make one complete revolution around, 2 pi is equivalent to 12 pi over 6. So then this is going to be actually 9 pi over 6. Again, if I was to convert 270 into radians. And obviously I could simplify this fraction to 3 pi over 2, but again, I want everything to have a denominator of 6. So now you can see exactly what quadrant 7 pi over 6 is going to fall in. 7 pi over 6 is going to have to fall somewhere in quadrant 3. So that's what 7 pi over 6 sketch looks like. And again, you can convert this into degrees by multiplying 180 degrees over pi. And again, I can cross out the pi's, and when I multiply, this is going to give me 210 degrees. So 5 pi over 12. Again, that's 0 degrees or 0 radians. This is 90 degrees, or pi over 2 in radians. With a denominator of 12, I can write this as 6 pi over 12. Because 6 over 12 is equal to pi over 2, which is what 90 degrees is equivalent to. This over here would be 12 pi over 12, which is just pi. So you can see then 5 pi over 12 is going to have to fall in quadrant 1. And again, we can convert this into radians by multiplying by 180 degrees over pi. So 5 times 180, and I'm going to divide this by 12, which is 75 degrees. Which you can see that I placed that in. So that's how you can convert radians into degrees and sketch the angles.